Hello friends, in this video we shall learn about lines and angles. I'm Samir and you are watching My Scholars. So our first topic is lines. So line is represented by a simple line segment with two arrows at the both end. So it shows that this is extending unlimitedly in both the sides, in that side and in this side, and represented by AB or a small line with two arrows at the end point. Second is ray. It has one initial point and no end point. This is extending unlimitedly from the side of Q, and it is represented by PQ, one arrow on one side like this, and there is a line segment. Third is line segment. It has limited length. The length of line segment is limited and it is expressed like this: XY, a small line over it. Second, angles. A figure formed by two rays with the common initial point is called an angle. So this is common initial point. O is the common initial point of these two rays. One ray is this and other ray is this. OP is one ray and OQ is another ray. Here O is the initial point, or which is called vertex. O is called vertex. There are two rays which are initiating from point O. The ray OP is called arm and ray OQ is also called arm of the angles. Arms or side of the angles. These are arms. This is also OQ is also arm or side of the angles. Arms or side of the angles. We denote it as angle POQ, keeping vertex in the middle. O is kept in the middle. Angle POQ, or we can also denote it angle QOP. In the adjoint figure of angle, point A and B are inside the angle, whereas point R and S are outside the angles. This way, there is a portion which is called inside of the angle and other is outside of the angle. Whereas P and Q, points P and Q are on the angles. Now the type of angles. Two rays are initiating from a common point O and they are overlapping each other going in the same direction. So this way they forms 0 degree angle. No any inclination is seen between these two rays. They are overlapping each other. Second is an acute angle. An angle whose measure is more than 0 degree and less than 90 degree is called an acute angle. means that the acute angle, value of the acute angle, angle AOB, when it is greater than 0 degree and smaller than 90 degree, it will be called an acute angle. An acute angle. This way, an acute angle is greater than 0 degree and smaller than 90 degree, i.e. it is between 0 and 90 degree. Right angle, an angle whose measure is 90 degree, is known as right angle, and it is explained and it is denoted like this by a small sign like this. So this way angle PQR is a right angle, and the measure of angle PQR is equal to 90 degree. Obtuse angle, an angle whose measure is more than 90 degree and is smaller than 180 degree. An angle whose measure is greater than 90 degree but less than 180 degree is called an obtuse angle. This way, in figure, angle PQR is an obtuse angle. A straight angle. PQR is an straight angle since its measure is 180 degree. If two arms of an angle lie along the same straight line as here QP and QR, but point towards opposite direction, then the angle is called a straight angle. And as I told you, its measure is always 180 degree. Reflex angle, an angle whose measure is more than 90 degree but less than 360 degree, is called reflex angle. Here LMN is a reflex angle since its measure is more than 180 degree and less than 360 degree. This way, an angle whose measure is greater than 180 degree but less than 360 degree is called a reflex angle. Complete angle, an angle whose measure is 360 degree is called complete angle. Here POQ is a complete angle since its measure is 360 degree. It is used to measure the sum of all the angles at a point. Suppose at point O there are so many angles, so we use sum of all these angles at a point is 360 degree. Adjacent angles, if two angles have common arm, a common vertex, and their non-common arms lie on either side of the common arm. We shall see the diagram. In the figure, AOB and angle BOC are adjacent angle. OB, which is red one, is the common arm, and O is the common vertex, which is written in black color. The arm OA is in green color and the arm OC is in blue color, are the opposite sides of OB. You can see this line is opposite. These two lines are opposite side of line OB. This way it is these are an adjacent angles. So this way Angle AOC, we can write angle AOC, AOC is equal to angle AOB plus angle BOC, angle AOB plus angle BOC. Complementary angles. If the sum of the measure of two angles is 90 degree, then the angles are called complementary angles, and each angle is called complement of other. Here ABD and DBC are complementary angles, or separate angle ABD and DBC are called complement of each other. Angle this way, angle angle ABD plus angle DBC is equal to 90 degree. They are complement of each other. These are supplementary angles. Two angles are said to be supplementary angles if their sum if the sum of their measure is 180 degree. If the sum of their measure is 180 degree, sum of the measure of these two angles is 180 degree, and these two angles also 180 degree. These two angles can be called supplementary angles also, these also, but these two angles cannot be called linear pair. These can be called a linear pair only. The angle formed on a line segment are called linear pair if their sum is 180 degree. These angles cannot be called linear pair, but they can be called supplementary angle, these two also. Vertically opposite angles. When two straight lines intersect each other, there are two straight lines PQ with green color and RS with blue color are intersecting at point O. Then the pair of angles so formed without any common arm are called vertically opposite angles. So this way angle 3 and angle 4, which are marked with green star, are vertically opposite angle, so as angle 1 and angle 2 are also vertically opposite angles, which are marked by red tick. We can prove very easily, as angle 1 plus angle 3 is equal to 180 degree, since the angles formed on a straight line ROS. This is equation 1, and so as angle 2 plus angle 4, angle 2 plus angle 4 is equal to also 180 degree. This is second. Now comparing first and second, angle 1 plus angle 3 is 180 degree, angle 1 plus angle 4 is also 180 degree, angle 1 plus angle 4 is also 180 degree. From first and second, If we compare first and second, angle 1 will cancel with angle 1. Angle 1 plus angle 3 is equal to angle 1 plus angle 4. Since angle 1 and 3 are formed on ROS and angle 1 and 4 are formed on POQ. So they are angle 1 plus angle 3 is equal to 180 degree and angle 1 plus angle 4 is equal to 180 degree. This way, from first and second, we can prove angle 1 will cancel from both the side. Angle 3 is equal to angle 4. Similarly, we can prove for angle 1 and 2. So this way, angle 3 and angle 4 are equal. Thus, if two lines intersect each other at a point, then vertically opposite angle so formed are equal. We will now study about intersecting lines, transversal and parallel lines, also angle made by transversal with two lines. First we are taking intersecting lines. Two lines L and M intersect if they have a point in common. Here point O is common. Two lines, line L which is in blue color and line M which is in green color, are intersecting at point O. Point O is common in both the lines blue and green. This common point is called the point of intersection. This is O is the point of intersection. Point of intersection. Transversal, a line which intersect two or more given lines in a plane at different points is called transversal to the given line. In the first diagram, L is the given transversal for two lines M and N. L is intersecting M and N at 2 points A and B. And in this diagram also there are two lines marked with blue color. Line L is intersecting these two lines at point P and Q. So this way line L is transversal for these two lines. And in this figure there are three lines M and O which are intersected by a line which is in red color L at 3 points X, Y and Z. So this way L is transversal for all these figures. Two lines in a plane are parallel. So there is a pair of parallel lines. If they do not meet when produced infinitely in either direction, they do not meet if they are produced infinitely in either direction. So this way these lines are called parallel lines. The opposite edges of a room, the opposite edges of a blackboard, railway lines, the opposite edges of ruler, etc. are the examples of parallel lines. We write them according to the given figure L parallel to M, like two lines and then M. L parallel to M. It is read as L parallel to M. Or we can also say that M parallel to N. M parallel to N. M parallel to N or L parallel to M. The perpendicular distance between two parallel lines always remains the same. Like the perpendicular distance between two railway tracks are always remains the same. Now we shall study about the angles formed by a transversal with two parallel lines. Here L and M be the two lines. These are two lines L and M, and another line N which is transversal intersecting these two lines at P and Q respectively. Clearly, line L, M and N makes total 1, 2, 3, 4, 5, 6, 7, 8. 8 angles in the given figure. These 8 angles marked by 1 to 8. Now we shall study about these angles. Interior angles. Angle 3, angle 4, angle 5 and angle 6 are interior angles. Since these are the angles whose arms include line segment PQ. The angles whose arm do not include PO are called exterior angles. This way, angle 1, angle 2, angle 7 and angle 8 are exterior angle since it do not include line PO. First we shall discuss about corresponding angles. Here angle 1 and angle 5 are the corresponding angles, so as angle 2 and angle 6 are the corresponding angles. Similarly, angle 7 and angle 3 are the corresponding angles. Angle 8 and angle 4 are the corresponding angles since they form F everywhere, like this. This angle and this angle, corresponding angle. This angle and this angle, corresponding angle. They are forming F-like structure. This angle and this angle, one after another. This angle and this angle. So this is angle 1 and 5. This is angle 7 and 3. Here. This is angle 2 and 6. And this is angle 3 and 7. Here we should write 4 and 8. 4 and 8. 3 and 7. This way, there are 1, 2, 3, 4 pair of corresponding angles. This way, a pair of angle in which one arm of each angle of the pair is on the same side of the transversal and the other arm of the angle of the pair are directed in the same side are known as corresponding angle. Alternate interior angles. A pair of angles in which one arm of each of the angle is on the opposite side of the transversal, like this or this, opposite side of the transversal, and the other arm is segment PO, is called a pair of alternate interior angles. Thus, angle 3 and angle 5, angle 4 and angle 6 are pair of alternate interior angle. Angle 3, angle 5, angle 4, angle 6. They form Z-like structure. This way, 3 and 5 are forming like this, and 4 and 6 are forming like this. Alternate exterior angles. A pair of angles in which one arm of each of angle is on the opposite side of the transversal and the other arm are in opposite direction and do not include line segment PO. This line segment is called a pair of alternate exterior angle. In the given figure, angle 1 and angle 7 are the pair of alternate exterior angles, and angle 2 and angle 8 are the pair of alternate exterior angles. Two and 8 are alternate exterior angle. Angle 1 and angle 7 are alternate exterior angle. Angle 2 and angle 8, angle 2 and angle 8, angle 2 and angle 8. Angle 1 and angle 7 are exterior alternate angles. If the lines L and M are parallel, then alternate interior angle will equal, this angle will equal to this angle will equal to this, and alternate exterior angle also will equal, corresponding angle will also equal. This way we have completed all the things about line and angles. Thank you for watching, my scholars. If you liked our video, please like and subscribe our channel. Thank you for watching, my scholars, again.